In this video we're going to take a look at using the calculator. Let me clear it out from the previous one here. Using the calculator to help us out with testing claims about means, testing claim about a population mean when we know the population standard deviation, when sigma is known. We'll have a different test when we don't know the population standard deviation and have to replace it with a sample standard deviation. So testing claim about a mean, mu, when we know sigma, when we know the population standard deviation. Alright, so the place that we'll go in the calculator to do that is again under Stat Tests, and this time Z-test, the very first one on there. We used one prop Z-test in the last section when we were testing claims about proportions. Mean is kind of the most common test, so they don't say mu test or anything like that. It's Z for normal distribution, Z-test. Okay, and we have two options there. We can either input the data itself if we have a list of all the data, or we can input statistics. Now usually with the problems that you're given, you'll input the statistics. Sometimes though, if you're given the raw data itself, then you can put in the data there. In our example, our first example here, we were given 106 body temperature readings of healthy adults, had a mean of 98.2 degrees Fahrenheit. We're not given the data itself, we're given statistics, so we'll use that option. If you do want to put the data in L1, then you can use this data option, but I want to go over and choose stats since we just have a summary of the data. Alright, we were testing a claim that mean body temperature is equal to 98.6 given that the standard deviation of the population of all body temperature readings is 0.62. We wrote down our claim and our opposite to get our H0 and H1. Mu0 then is the value of a mean from our H0, the one that comes from the claim, 98.6. Kind of our old accepted value that we're used to for what body temperature should be, or what we think it should be at least. And then 0.62 was our sigma. Again, notice that it's asking for sigma there. If it asks for S, which it will later on in t-test, then we'd have to put in a sample standard deviation. This is a population standard deviation, so it gives you one last chance there to verify that you're using the correct test. Alright, then our X bar is our sample mean. Our mean of our 106 body temperature readings was 98.2. and that N was 106. And then we have to decide on which version of H1 we have to decide what kind of test. This one was not equal to 98.6. The opposite of our claim was not equal, so that ended up becoming our H1. That ended up becoming our alternative hypothesis. Alright, so we can go down and hit enter on calculate there. Gives us the test statistic, same as we calculated by hand. Gives us a p-value, almost the same as we calculated by hand because we had done a little bit of rounding there, I think, but basically the same. And it's a very small p-value again, you notice. 3.1 times 10 to the minus 11. Again, a p-value of 3 doesn't make sense. Has to be less than 1, so you have to watch for that scientific notation there. And basically anytime that scientific notation shows up, you have a very small p-value. And so it'll always be a negative, 10 to the negative number there. So we get 3.1 times 10 to the negative 11, very small p-value, less than 0.05. So we rejected our null hypothesis on that one. And again, let's look at that wording of the final conclusion just to see if that's any different this time, because it will be. And let's see, did our original claim contain the condition of equality? Well, this time, yes, it did. Our original claim was that the mean is equal to 98.6. So that is equality. Not only does it contain equality, but it is equality. So we'll follow the yes arrow on our flowchart this time. Original claim does contain equality. Did we reject H0? Yes, we had a very small p-value and we rejected the null hypothesis. So our conclusion is that there is sufficient evidence to warrant the rejection of the claim that mean body temperature is equal to 98.6 was the claim that we were testing. Okay. So what we've done there is that sample evidence is strong enough to say that mean body temperature is different than 98.6. We've rejected the claim that mean body temperature is 98.6. So that old accepted value that we're used to, we now have evidence to say that it might be false. And we're not saying specifically which side of it's on, whether it's less than or greater than. We're just saying that it's not equal to 98.6 if we're rejecting that claim that it is equal to 98.6. It looks like based on our sample that it's a little bit less than 98.6, but we don't. Our test that we did doesn't specify one way or the other. It's a two-tailed test, so it doesn't give us a particular direction there. Okay, one more example that we did in those notes with bumblebee bats, sample of bat weights. We had a sample of 15 bats with a mean weight of 1.71 grams. We were assuming that the weights of all small bats had a normal distribution with a standard deviation of 0.3 grams. That gives us that population standard deviation sigma. Again, not from our sample of 15, but from the entire population. So with alpha equals 0.10, we wanted to test the claim that that this sample of 15 bats comes from a population with a mean weight less than 1.8 grams. So our claim was mu less than 1.8. Notice it does not contain equality. That'll help us out once we get to the flowchart later on. That makes our H0, our null hypothesis, equals 1.8, always equals, and then our H1 was that original claim since it did not contain equality. We didn't end up needing the opposite on that one. Alright, so again, we'll go to z-test to find that, number 1 on our stat tests list. Okay, again, we don't have that list of the actual bat weights. If we did, we could put that into L1, stat, edit, and put those in L1, and then use our data option under z-tests. But we have a summary of that information. We have the statistics. So our mu0, the mean that we're comparing to on our claim, is 1.8. Mu0 coming from the H0. And our sigma, our population standard deviation, again, it's giving you a chance to realize that that's a population standard deviation. Oops, sorry, that was the old one, 0.30. That we have a population standard deviation instead of a standard deviation of our sample of 15 bat weights there, which is maybe not so realistic but if we have some kind of information about the population to begin with, then maybe that gives us a reason to know that population standard deviation. Alright, and then our x bar, our mean weight of our sample, was 1.71 as compared to that 1.8 for the value from the claim that went into our H0. Our n was 15 bats. Notice that n was smaller than 30 again. That's what we needed, that normal distribution statement there to save us, to take care of that. And then our alternative hypothesis, H1, had less than, because our claim did not contain equality, so it became a left-tailed test with a less than in our H1. Alright, we'll go down to calculate, or again, if you like, you can go to draw. I'll show you that one more time, just like last time. A left-tailed test, so that left tail is shaded. How much of it is shaded is that p-value, and the boundary for that shaded area is our test statistic there. So our test statistic was negative 1.162, and the p-value is 0.1226. Again, you can find it without doing the draw option as well. It gives you the same information just without the picture if you just go to calculate. And there we go. Same information there, same test statistic, same p-value. That p-value this time was relatively large. Notice no scientific notation on that one. It starts with the decimal, so it's 0.1226. We don't have that times 10 to the negative anything at the end. So that ended up being bigger than our alpha, and bigger than most any level of significance that we'd use. So because it's bigger than alpha, we fail to reject that null hypothesis, and then we go on to wording that final conclusion. Again, that final conclusion this time, let's see, our original claim did not contain equality this time. We wanted to know, was that mean less than 1.8, not less than or equal to, so the equality was not in there. Our original claim became H1 there. It reminds you of that in parentheses. Did we reject H0? No, we didn't this time, so we end up in the bottom box. There is not sufficient sample evidence from our sample of 15 bats to support the claim that the mean weight of the population of these bats is less than 1.8. The idea behind that on this one was bumblebee bats are supposed to have an average weight of 1.8. We found some bats that seemed a little bit lighter, but they're not significantly lighter is what we found there. There's not enough evidence to support that claim that our mean was less than 1.8 as we were testing. Okay, so that's again using the calculator to help us out with hypothesis tests for a mean. Excuse me, when we know the population standard deviation, when we know sigma. That'll be as compared to t-tests that we'll study next for when we don't know the population standard deviation, when we have s instead of sigma. So that's where we're headed next, and we'll see what the differences are once we get there.